Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers ratio. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 9. A drink is mixed in the ratio of lemonade to orange to cranberry of 6 to 3 to 2. What fraction is orange? Circle your answer. Okay, so if the ratio is 6 to 3 to 2, that means there are 6 parts lemonade, 3 parts orange and 2 parts cranberry. So altogether, how many parts is that? Well, 6 plus 3 plus 2 is equal to 11. So it's 11 parts altogether. Now we want the fraction that is orange, which is the one in the middle, which is the 3. So the fraction that is orange is going to be your 3 orange parts out of your total 11 parts, which is that one there, 3/11. Question 18. The ratio of x to y to z is in the ratio of 2 to 3 to 5. Circle the value of x as a fraction of x plus y plus z. Okay. Confusing much? Not really. If I've got a ratio of 2 to 3 to 5, then how many parts is that altogether? 2 plus 3 plus 5 is equal to 10. So there are 10 shares, aren't there, between x, y, and z. So then what fraction is x out of x plus y plus z? It's just going to be the 2 parts out of 10 parts, or 2/10. Okay, do I have a 2/10 in the list? I don't, but luckily 2/10 is the same thing as 1/5. So my answer is that one. Question 4. Which ratio is not equivalent to the ratio of 3 to 4? Circle your answer. So if I got the ratio of 3 to 4, if I make the 3 into a 1, so if I divide this by 3 and divide this by 3, that's going to give me 1 to 4/3. So that one is okay. If I made the 4 into a 1, so if I divide it by 4 on this side and 4 on this side, that's going to give me 3/4 to 1. So that one is okay. And if I take 3 to 4 and I times it by 2 on both sides, that's going to give me 6 to 8. So that one is okay. So just by a process of elimination, that one must be the one that doesn't or isn't equivalent to 3 to 4. Question 16. The counters in a bag are red or blue. 1/5 of the counters are red. Work out the ratio of red counters to blue counters. Okay, so the ratio of red to blue, what is that going to be then? Now we're told 1/5 of the counters are red. So if I've got 1/5 of the counters are red, what proportion is left of that must be blue then? So a whole take away 1/5 leaves 4/5. So that must be 1/5 red, 4/5 blue. Now if I then multiply both of those by 5, then I'm going to get the ratio 1 to 4, aren't I? So the ratio of red counters to blue counters is that one there, 1 to 4. 11a. Cards in a pack are red or blue in the ratio of red to blue is 2 to 3. What fraction of the cards are red? Circle your answer. Well, if they're in the ratio of 2 to 3, then there are 2 parts red and 3 parts blue, which means altogether there are 2 plus 3, there are 5 parts. Okay, so then that means that the fraction of that are red are 2/5 and the fraction that are blue are 3/5. Okay, so what fraction of the cards are red? It's that one there, isn't it? 2/5, that one. Question 17. Here is some information about a group of children. I've got boys and girls, left-handed, right-handed. So this is what we call a two-way table. I've got 3 left-handed boys, 12 right-handed boys, 3 left-handed girls, and 20 right-handed girls. Write down the number of left-handed girls to right-handed girls as a ratio. Okay, give your answer in its simplest form. Left-handed girls to right-handed girls, then is going to be 8 to 20. Okay, can we cancel that down at all? So common factors of 8 are, well, factors of 8 are 1, 2, 4, and 8. Factors of 20 are 1, 2, 4, and 5, and 20. So I think we can divide both of those numbers by 4, can't we? So dividing by 4, I should get a ratio of 2 to 5 in its lowest form. Part B. Question 5. 15 rulers cost £3. How much do 40 rulers cost? Now, this particular question lends itself to a method known as the Unitary method, which is a ratio approach. The Unitary method is called that because it goes via 1. A unit means 1. So what we do is we set up a ratio between our two amounts. So we've got rulers and we've got cost. Okay, and so we've been given one ratio between the two to start with. We're told that 15 rulers costs £3. So 15 rulers to £3 is the ratio. And we want to find what the cost of 40 rulers is. Okay, so we can do that as a ratio. We're going to scale up our ratio from 15 to 3 to 40 to something. And then this number here then is going to be our answer. Okay, and now it's called the Unitary method because we're going to go via 1. So first off, we work out the ratio of 1 to something. So now we want to move from 15 to 1, which means divide by 15. And we have to do the same thing over here on this, so we're going to have to divide by 15 here. So this is a job for our calculator. So typing that in, 3 divided by 15 is 0.2. So let's put in 0.2 here. And then from 1, we need to scale up now to 40. So you're going to have to times through by 40. So it's taking our 0.2 and timesing that by 40 as well. 0.2 times 40 gives me 8. So that number in there should be an 8. So how much do 40 rulers cost? It costs £8. There are between 25 and 35 students in the class. The ratio of boys to girls is 4 to 7. How many students are there in the class? Well, if the ratio is 4 to 7, then the number in the students in the class has got to be a multiple of 4 plus 7. It's got to be a multiple of 11. And the only multiple of 11 between 25 and 35 is 3 lots of 11, 33. So there must be 33 students in the class. Question 7a. 2 tubs of ice cream cost £5.90. How much would 5 of these tubs cost? Now I like to do these questions using a method called the Unitary method, which is a ratio approach. Let's start off by creating a ratio between the tubs of ice cream I've got and their cost. And we're given that 2 tubs is the same thing as £5.90. So that's going to be my initial ratio. Now I want to know how much 5 tubs cost. So my answer is going to be what I work out here. Okay, but it's called the unitary method because we go via the value of 1. So what we need to do is we need to take our 2 tubs, divide it by 2 to find the cost of 1 tub, and then scale it up by multiplying it by 5 again to find what 5 tubs cost. So doing the same on this side, if I take £5.90 and I divide it by 2, so £5.90 divided by 2, that gives me £2.95. £2.95, and then multiplying that by 5 next, so doing the same as what I did on the other side, times 5, that gives me £14.75. £14.75. So that's the cost of 5 tubs then. So my final answer is £14.75. Question 17. Harry is tiling a wall of area 25 square meters. A tub contains 15 kilograms of tile cement, and the instructions say 2 kilograms of tile cement will tile 1 square meter of wall. So how many tubs does Harry need to buy? Okay. So we can set up a ratio here, can't we? We can say that the amount of cement to the amount of wall is the ratio from here. Look, 2 kilometers it will tile 1 square meter. So I can say that 2 kg of cement tiles 1 meter of wall. Now we want to wall an area of 25 square meters. So we need to take our ratio and increase it up to, scale it up to 25. So we're timesing up by a factor of 25. So doing the same thing over here, multiplying that by a scale factor of 25. 2 times 25 gives me 50. So I need 50 kgs of cement. Okay, now a tub contains 15 kilograms of cement. So how many tubs am I going to need? Well, how many times does 15 go into 50? So 15, 30, 45, 60. So 3 tubs would be 45, which is not quite enough. 4 tubs is 60, which is more than what we need, but we can't have less than what we need, and we can have a little bit left over. So it's going to be that one there, isn't it? 4 tubs. Says in part B, in fact, Harry uses more than 2 kilograms of tile cement per square meter. Without needing to buy more tubs, what is the maximum amount he could use per square meter? Okay. So he's got 4 tubs, and we know that 4 tubs equals 60 kg of cement. So the maximum he can use, maximum used, is going to be my 60 kilograms of cement divided by my 25 square meters. Now, if I had a calculator, I might just type that in, but I don't. So I'm going to just do it using a fraction method, really. So consider this to be a top-heavy fraction. See if we can simplify it down. How many 25s go into 60? Well, 25 goes into 60 twice. Remainder 10. So that is the same thing as 2 and 10 25ths. And 10 25ths I can divide, or I can cancel 10 25ths down, can't I? If I divide top and bottom by 5. That's the same thing as 2 and 2/5. So that's my answer then. I can use 2 and 2/5. But what's 2/5 as a decimal? That's the same thing as 2/5 is the same thing as 4/10. So that's the same thing as 2.4 kilograms. There are between 25 and 35 students in the class. The ratio of boys to girls is 4:7. How many students are there in the class? Well, if the ratio is 4:7, then the number in the students in the class has got to be a multiple of 4 plus 7. It's got to be a multiple of 11. And the only multiple of 11 between 25 and 35 is 3 lots of 11. 33. So there must be 33 students in the class. Question 13. Before an election, 23% said they would vote for A, 9% said they would vote for B, 20% said they would not vote. These all voted as they said. The rest of the population actually voted for A and B in the ratio of 1:2. Who got the most votes? You must show your working. Okay. Now notice that they don't give you a total number of people here. So what you can do is just assume it's 100 or some multiple of 100. That's probably the easiest way. So assume you've got 100 people. Then what have you got? You've got 23 for A and B and neither. You've got 23 people voting for A, 9 people for B, and 20 not voting. So how many is that then? That is 23 plus 9 is 32 plus 20. So that gives you 52 people so far. So we've got another 48 people to allocate then, don't we, to our voting table. Okay, so we've got another 100, subtract 52. We've got another 48 people to allocate. And if I divide that into the ratio of 1:2, because that was the ratio that they voted in, 1 part to A, 2 parts to B, divided by ratio, 1 plus 2 is 3. So I need to divide 48 into 3 parts. So 48 divide by 3. 3's into 48. Go 16 times. And then I'm going to take my ratio of 1:2 and I'm going to multiply it up by a factor of 16. So that gives me 16 votes for A, and 2 times 16, 32 votes for B. So we're going to have another 16 votes for this guy and 32 for B. So then the total votes cast then, A got 23 and 16, and that gives them a total of 39. B got 9 and 32, which was 41, and a 20 voted for neither. So a victory for B and a failure for the pollsters yet again, who predicted A. So the answer is, what's the question? Who got the most votes? B got the most votes. Right, so it says here that 612 people did not vote. How many did vote? Okay, now remember earlier we assumed 100 people just to give us some figures to work with. So that meant that all of these were percentages actually, because they were all out of 100. Okay, now we're told the actual value now of one of these. We're told that 612 people did not vote. So this 20% here is our 612 people. So what we've got is 20% of people represents 612 people. So if 20% of people didn't vote, then I figure that 80% of people must have voted. Does that make sense? So if 20% didn't vote, then the rest of them, 100 subtract 20% is 80%. That means that 80% did vote, which is 4 times as big as 20%. So if I take 612 and times it by 4, I should be able to work out how many people did vote. So 612 times by 4 gives me 2,448. 2448. So that's the number of people who voted, 2,448. Question 6. The sum of two numbers is 35. The second number is 4 times the first number. Work out the two numbers. Now, if you were sitting in a higher tier paper, I might encourage you to take an algebraic approach here. But most people doing foundation are doing it because they find algebra tricky. So let's try answering this question instead using ratios. I'm told here that my second number is 4 times the first number, so I can express that as a ratio. I can say the ratio of the first number to the second number is in the ratio of 1 to 4. Okay? And then because the sum of the two numbers is 35, essentially what we're going to do here is going to just divide by that ratio. So if I divide 35 by the ratio of 1 to 4, I should be able to find out what the two numbers are worth. Okay, so when you divide by a ratio, what do? You add the two parts together of the ratio, don't you? So 1 plus 4 is 5, meaning there are 5 parts. And then we're going to divide our total, 35, by our 5 parts. So 35 divided by 5 gives me 7. That means that each part must be worth 7. So my ratio of 1 to 4, I can then scale up by a factor of 7. So multiplying both these parts by 7. So 1 times 7 is 7, and 4 times 7 is 28, meaning that my two numbers must be 7 and 28. Question 15. In a school show, the ratio of girls to boys is 1 to 1, which means there is just as many girls as there are boys. Girls who sing to girls who do not sing is 1 to 2. So twice as many girls don't sing as do. There are 8 girls singing in the show. How many students are in the show altogether? Okay. So if the ratio of girls who sing to the girls who do not sing is in the ratio of 1 to 2, and we know that the girls who sing is 8, then this one here is timesing through by 8. So doing the same to the other side, timesing by 2, there must be 2 times 8 is 16. There must be 16 girls who don't sing. So how many girls is that altogether? 8 plus 16, it gives me 24 girls. Okay. Now the ratio of girls to boys was 1 to 1, so that must be that there's also 24 boys. So then the total in the show is going to be the number of girls plus the number of boys, which is going to be 48. So there are 48 students in this show. Question 19. Ben and Katie throw darts at a target. Ben's ratios of hits to misses is 5 to 1, which means he's getting about 5 hits for every 1 miss. Katie's ratio of hits to misses is 3 to 1. Ben says 5 is bigger than 3, so I must have more hits than Katie. Give an example to show that this might not be true. Okay, so a ratio is just the amount of hits to misses. So let's say that Ben threw 6 times. So if Ben throws 6 times, then he has 5 hits and 1 miss. Okay, so let's have a look at Katie. She hits 3 times for every 1 times she misses. So 3 plus 1 is 4. So in the fourth row, she hits 3 times and misses once. But let's say she did that over again. So she hit another 3 and missed another one. That's a total of 6 hits and 2 misses. So Katie could throw 8 times, gaining 6 hits and 2 misses. Okay, so we've given an example, haven't we? So we've given an example to show that this might not be true. So if Ben throws 6 times, he gets 5 hits and 1 misses, and Katie could throw 8 times, gaining 6 hits and 2 misses. So she's hit more times than he has. Question 17. CD and PQ are lines of length 12 centimeters. And we're told that the ratio of CE to CD is 1 to 2. Mark point E on the line with a cross. Okay, CD and PQ are both lines of length 12. Okay, so here's CD. PQ is a bit further down on the page, so this is 12. And actually, you've got the 12 digits on here, haven't you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's been already marked up into 12 sections. So if we're told that the ratio of CE to CD is in the ratio of 1 to 2, and we know that CD is actually of length 12, well, I can see that 2 times 6 is 12, so this one must be times 6 as well. That should be, CE should be 1 times 6, which is 6 units in length. So mark E on the line with a cross. It's going to be 6 units up from C. 1, 2, 3, 4, 5, 6. It's going to be here. Okay. And then we're told that PR to RQ is in a ratio of 1 to 3. Mark the point R on the line with a cross. So notice R is the one in the middle of these. The ratio for the distance from P to R, the point we need to mark, compared to R to Q, is in the ratio of 1 to 3. So basically, we've got to divide up this line in the ratio of 1 to 3 to work out where R is. So it's a bit like one of those questions where you have to divide a number by a given ratio. Add in the two parts of the ratio together. 1 plus 3 is equal to 4. So then if we take the length of our line 12 and divide it by 4, we can see that gives us the answer 3. So that means if we take our original ratio 1 to 3 and I scale it up by a factor of 3, because that's the number I just found here, that's going to give me 3 to 9, which means my point R is going to be 3 units from P and 9 units from Q. It's going to be that point there. Did I label that one? I should really label that as well. That's E, that's R. Okay, done. Question 19a. Divide 120 in the ratio of 1 to 4. Okay, now when we're dividing into a ratio, we need to take our ratio, our 1 to 4, and add the two parts together. That means that we're dividing our number into 5 parts. Okay? So we're dividing the number into 5 parts. Now what is the value of each one of those parts? We can work that out by taking 120 and dividing it by the number of parts. 5's into 120. 120 divided by 5 is 24. Okay, so each one of those parts is worth 24. So if I then go back to my original ratio 1 to 4 and multiply each part by 24, I'll know how much each part is worth. So 1 times 24, that's easy, that's 24. And the other one, 4 lots of 24, is 4 times 24, 96. Okay, so my answer is 24 and 96. It's always a good idea just to double check by adding those together. I can see that they add up to 120. So that's good. Right, now part B says, write the ratio 7 to 4 in the ratio of n to 1. In other words, I need to divide. If I want to make that bit 1, I'm going to have to divide both sides by 4, aren't I? Okay, now obviously 7 doesn't divide by 4, so it's not going to give me a nice number. I'm just going to write it like this, 7 over 4. That's good enough. So 7 over 4 to 1. Some people don't like fractions, but really it makes life easier for you. 7 over 4 to 1. Now I could write that as a decimal. That is, what, 1.75? But it doesn't tell me I have to write it as a decimal. So I'm just going to leave it like that. Question 5. 2.5 kilograms of carrots cost £1.70. Work out the cost of 3.25 kilograms of carrots. Now I'm going to use a method here, a ratio method here called the unitary method. So we're going to start with our weight of carrots and our cost of carrots that we were given. Now we're told that 2.5 kilograms of carrots cost £1.70. So I'm going to write that in as a ratio. 2.5 goes with 1.7. Okay, and it's called the unitary method because it means you go via a unit or the number 1. So I'm going to work out the cost of 1 kilogram of carrots, and then I'm going to scale it back up and work out the cost of 3.25. Now in order to do that, I need to take this value, I need to divide it by 2.5, and then I need to times it by 3.25. So if I do that on the left hand side of my ratio to make things all stay in proportion, I'm going to do the same thing on the other side. So divide by 2.5 first and then times by 3.25. So reaching for a calculator, I just type in 1.7, divide it by 2.5 to find the cost of 1 kilogram, and then times it by 3.25. Don't really need to write down the middle value if I don't want to. It's just the answer down here that I need to find. So 2.21 is the solution, isn't it? So that means that 3.25 kilograms of carrots costs £2.21. Question 19. Use 2 gallons equals 9 litres to convert 17 gallons into litres. Now, I can write gallons to litres as a ratio. So 2 gallons we said was equivalent to 9 litres. So what we want is to turn that 2 into 17. Okay. So how are we going to do that? We can try using the unitary method. We can say, well, if 2 gallons is 9 litres, then 1 gallon I can get by dividing that by 2, and dividing 9 by 2, I'm going to get 4.5, aren't I? So 1 litre is equivalent to 4.5 litres. So then if I then want to work out what 17 gallons are, I can times that by 17. So times in 4.5 by 17, what do I get? How do you do your multiplication? Different ways of doing multiplication. I quite like Napier's bones as a method of multiplying. So 17 and 4.5 that way. So 1 4s are 4, 7 4s are 28, 1 5 is 5, and 7 5s are 35. Adding up along the diagonals. 5, 8, 3, and 5 make 16. Carry 1, so 2, 4, and 1 makes 7. So that comes out to be 765. 765. But I had a decimal point there, so I'm going to have a decimal point here. So that comes out to be 76.5. 76.5 litres. You might multiply differently. You just need to have a method that works for you. Question 10 gives us the instructions from a bottle of squash. To make fizzy juice, mix 2 parts fruit squash with 7 parts lemonade. So it's given us a ratio. I'm going to write that down underneath. Ratio of juice to lemonade. So, sorry, ratio of squash. Squash to lemonade is in the ratio of 2 to 7. Okay, Tom has 80 milliliters of fruit squash. He also has 210 milliliters of lemonade. 2 times 40 is 80. So times in 7 by 40. I'm going to get 740. 7 fours are 28 plus a 0 is 280. So that's 280. But that is too much. He doesn't have 280 milliliters of lemonade. He's only got 210. So the most he can make then is if he has 210. Now to go from 7 to 210 is times by 30. So then if I times this one by 30, I'm going to get 60. So for my 210 milliliters of lemonade, I'm going to have to add 60 milliliters of squash. So what is the maximum amount of fizzy juice he can make is those two amounts added together. So maximum fizzy juice is going to be my 60 milliliters of squash plus my 210 milliliters of lemonade, giving me a total of 270 milliliters of fizzy juice. Question 5. There are between 25 and 35 students in the class. The ratio of boys to girls is 4 to 7. How many students are there in the class? Well, if the ratio is 4 to 7, then the number in the students in the class has got to be a multiple of 4 plus 7. It's got to be a multiple of 11. And the only multiple of 11 between 25 and 35 is 3 lots of 11, 33. So there must be 33 students in the class. Question 9. Here are 2 piles of the same type of paper. Each sheet of paper is 7/1000th of a centimetre thick. The taller pile is 10.5 centimetres high. The height of the taller pile to the height of the shorter pile is 3 to 2. Work out the number of sheets of paper in the shorter pile. So we've been given quite a bit of information here, and we have to kind of work out a plan, I suppose, the order that we're going to have to use these bits of information to get from question through to answer. Okay, so I'm going to use the ratio first to work out the height of the shorter pile, and then I'm going to use the thickness of the paper to work out how many sheets of paper are in it. Okay, so let's take the ratio first. This is in the ratio of 3 to 2. 3 to 2. But the height of the left-hand side is 10.5 centimetres, and we want this number here then. So to go from 3 to 10, we can divide by 3 and then times by 10.5. That's called a unitary method, going via 1. Okay, and we're going to do the same on this side as well. So we're going to take 2, we're going to divide it by 3, and then we're going to times it by 10.5 as well. So let's get the calculator out. 2 divided by 3 times by 10.5 gives me 7. So this number in here should be 7. So that tells me that the height of my smaller part is 7 centimeters tall. Now I know the height of it. I know that each sheet of paper is 7/1000ths. So what is 7 divided by 7/1000ths? Well, when I divide through by a fraction, that's the same as flipping over and times in. So 7 times 1000 over 7. Now you can see that those 7's are going to cancel off, and that's going to leave me 1000. So there are 1000 sheets of paper. Question 11. The angles in triangle A are in the ratio of 1 to 2 to 3. The angles in triangle B are in the ratio of 4 to 5 to 6. Now Jack says the middle number in each ratio is 1/3 of the total. So one of the angles in each triangle is 60 degrees. Is he correct? Okay, there's probably 101 ways of doing this, but I think what I'm going to do is work out what the middle angle is for each of these. That seems to be the easiest and straightforward way of doing it. So let's start with triangle A, which is in a ratio of 1 to 2 to 3. So in triangle A, our ratio of 1 to 2 to 3 gives us 1 plus 2 plus 3 parts, which is 6 parts. And we've got 180 degrees to share out, so 180 divided by 6, and then times by 2 is going to be our middle angle, which is 60 degrees. In triangle B, our ratio is 4 to 5 to 6, which, if I add those up, 4 plus 5 plus 6 is equal to 15 parts. And then 180, which is the angles in a triangle, divide by our 15 parts and times by 5, again is 60 degrees. So it looks like Jack is correct. So Jack is correct. Question 11. Purple paint is made by mixing red paint and blue paint in a ratio of 5 to 2. Jan has 30 litres of red paint and 9 litres of blue paint. What is the maximum amount of purple paint she can make? Okay, so the ratio of red to blue is, well, it needs to be 5 to 2. Okay, so if I increase this ratio, so I increase the amount of red paint required from 5 to 30, I would be multiplying through this ratio by a factor of 6. So I'd have to do the same this side, which means for 30 litres of red paint I would require 12 litres of blue paint, but I don't have 12 litres of blue paint. I've only got 9, so that is not possible. So the best I'm going to be able to do is to make blue equal to 9. So what do I have to multiply 2 to get 9? I have to multiply it by 4.5, don't I? It's 4.5 times bigger. So if I multiply 5 by 4.5, it means, what's that? 5 lots of 4.5, 9, 18, 22.5 litres of red paint. So what's the maximum amount of purple paint that she can have? Well, I suppose when you add 22.5 litres of red paint to 9 litres of blue paint, then altogether you're going to have 22.5 plus 9 litres of paint, which is 31.5 litres. So she's going to have 31.5 litres of purple. Question 8. Theo starts with savings of £18 and James starts with no savings. Each week from now, Theo will save £4.50 and James will save £4. Okay. In how many weeks will Theo and James have savings in the ratio of 15 to 8? Ooh, that's not very nice. Theo starts with savings of £18. Okay. Now I suppose you could think of this as two linear equations, couldn't you? So Theo starts with savings of £18 and then, so he starts with 18 and he saves £4.50. So if we did it like a graph, a y and x graph, then, you know, x could be the number of weeks and y can be the total savings. So Theo would start on 18 and then every week he would save £4.50, so it'd increase by £4.50 and so on, and another £4.50, and it would give you a straight line graph, wouldn't it, like that, with the equation y is equal to 4.5x because he's saving £4.50 every week, plus 18, which is your y-intercept, isn't it? So that's y equals 4.5x. Oops, I should have written it where you could see it. Y equals 4.5x plus 18. So that's Theo's. Now James starts with no savings, and he saves £4 each go. So he's going to start on 0 then, isn't he? And then he's going up by 4 each time. So kind of 1 along 4 up. So slightly less steep than the graph we've just drawn, and isn't it? It's going to have a slightly less steep gradient. So these graphs are going to be diverging over time, aren't they? Theo is going to start ahead and he's going to get more ahead over time. And the equation of that line then is going to be y is equal to 4x plus nothing. Okay, so then my two graphs then, and then so in how many weeks will in how many weeks will Theo and James have savings in the ratio of 15 to 8? So we've got to find a time where if we took a slice down here and we compared that point and that point, then one would be 15/8 of the other, which is not so nice. So like I say, clearly Theo is earning more and will continue to earn more, and the gap between them is going to get wider and wider. So it's going to be him who has the 15 and James who has the 8, isn't it, at that point? Okay, or you know, the equivalent ratio. So in other words, this value up here is going to be 15/8 of that one, isn't it? Okay, so if I take that equation then, 4.5x plus 18, I suppose what I'm saying then is I want to find the value of x when that is equal to 15/8 of 4x. Okay, so what I'm saying is that's my yellow equation, isn't it? 4.5x, and this is my green one down here. So my yellow equation is 15/8 of my green equation. So then I've got an equation in x that I should be able to now go on and solve. Shall we try and do that then? So 4.5x plus 18 equals 15 lots of 4x over 8. Okay, let's just multiply out the bracket on the right. So 15 fours is 60x over 8 equals 4.5x plus 18. I'm tempted to cross multiply that 8 to get rid of it. So let's take that 8 and kind of move it over here. So that's going to give me 8 lots of 4.5x plus 18, and that's equal to 60x. Right, so multiplying out the brackets, 8 times 4.5 is 8 times 4.5. Could do it in my head, but I've got a calculator. So that's 36x plus 8 times 18. What's that? 8 times 18. That's 144. So I've got 36x plus 144 equals 60x. So let's subtract 36x from both sides. So that will leave me with 144 on this side and 60. Subtract 36, 24x over here. And then divide both sides by 24. I'm going to get 144 over 24. And that's going to be equal to my x. What's that on the calculator? 144 divided by 24. That equals 6. So x equals 6. So we're saying after 6, was it weeks? Yeah, 6 weeks. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.